Welcome to another journey through the cosmos, where science meets wonder and mystery dances with mathematics. I'm so glad you're here, settling in for what promises to be a fascinating exploration of something that shouldn't exist, yet does. Before we begin, I'd love to know where you're listening from tonight. Are you tucked beneath covers in a quiet bedroom, perhaps watching stars through your window? Or maybe you're in a cozy corner somewhere, letting curiosity guide you towards sleep. Wherever you are, take a moment to get comfortable, because what we're about to discuss will gently challenge everything you thought you knew about visitors from beyond our solar system. Now, if this exploration proves too intriguing to let you drift off immediately, well, at least you'll fall asleep, having learned something extraordinary. And if you enjoy these cosmic journeys, a gentle like or subscribe helps this little corner of the universe grow and reach other curious minds like yours. On July 1st, 2025, at 3:47 a.m. local time, a telescope in Chile detected something that shouldn't exist. Moving through the darkness beyond Jupiter's orbit was an object traveling at 137,000 miles per hour, faster than anything humanity had ever observed entering our solar system. But speed alone didn't make this discovery extraordinary. What made astronomers around the world stop their morning coffee mid-sip was the realization that this object, now designated 3I Atlas, was following a trajectory so precise, so mathematically elegant in its approach to multiple planets, that it appeared to be navigating rather than drifting. This is the third confirmed interstellar visitor to our solar system, joining the mysterious 1I Oumuamua in 2017 and the more conventional 2I Borisov in 2019. But 3I Atlas is different, profoundly different. Where its predecessors raised eyebrows, Atlas is raising alarms among a small but growing group of scientists who are beginning to ask a question that would have been dismissed as science fiction just a few years ago. What if this isn't a comet at all? The object measures between 440 meters and 5.6 kilometers across, making it potentially the largest interstellar visitor we've ever detected. But size isn't what's keeping researchers awake at night. It's the pattern, the deliberate, almost choreographed way it's moving through our solar system, as if following a predetermined flight plan written by an intelligence that understands celestial mechanics better than we do. Let me paint you a picture of what 3I Atlas is doing. Imagine you're watching a dancer move through a crowded room, weaving between people with such precision that they never touch anyone, yet come close enough to each person to whisper a secret. That's what Atlas is doing with our planets. It will pass within 1.6 astronomical units of Earth, swing by Mars at a comfortable distance, and execute what can only be described as a gravity-assisted tour of Jupiter before heading back into the interstellar void. The mathematical probability of a random object naturally following such a path is so small that it ventures into the realm of the impossible. Dr. Martin Cordiner, an astronomer at the Catholic University of America, was among the first to study Atlas with the James Webb Space Telescope. What he found challenged decades of assumptions about comets and interstellar objects. The carbon dioxide to water ratio we're seeing, he explained in hushed tones during a recent interview, is unlike anything in our database. It's not just unusual, it's unprecedented. 8:1 carbon dioxide to water. That's 6 standard deviations above normal. In statistics, that's not an anomaly, that's a signature. But it's not just the chemistry that's unusual, it's the timing. Atlas has been traveling through the galaxy for an estimated 3 billion years, longer than our solar system has even existed. Think about that for a moment. When this object began its journey, our sun was nothing more than a wisp of gas and dust in a stellar nursery that wouldn't collapse for another 3 billion years. Earth was an impossibility, life was unimaginable, and yet something launched Atlas on a trajectory that would bring it here, now, at this precise moment in cosmic history when we have developed just enough technology to detect it and just enough knowledge to realize how strange it truly is. Harvard astrophysicist Avi Loeb has never been one to shy away from controversial ideas. The same scientist who suggested that Oumuamua might have been alien technology has now turned his attention to Atlas, and what he's discovered has led him to invoke one of the most chilling theories in all of science, the dark forest hypothesis. The dark forest theory, first popularized in Liu Cixin's science fiction trilogy, suggests that the universe remains apparently empty, not because life is rare, but because intelligent civilizations actively hide from one another. Like hunters in a dark forest, they remain silent and invisible, knowing that revealing their location to unknown entities could mean extinction. It's a universe where first contact isn't a celebration, but a death sentence, where the silence we perceive isn't emptiness but fear. Loeb's recent paper, provocatively titled "Is the Interstellar Object 3R Atlas Alien Technology?" explores the possibility that Atlas represents exactly the kind of probe a civilization might send if they wanted to study other worlds while remaining hidden. Not a ship designed for conquest or communication, but a sophisticated surveillance system, gathering data on emerging civilizations before they become a threat or an opportunity. The consequences, Loeb wrote in his analysis, should the hypothesis turn out to be correct, could potentially be dire for humanity and would possibly require defensive measures to be undertaken. These aren't the words of a science fiction author or a conspiracy theorist. They're the carefully chosen phrases of a tenured Harvard professor who has spent his career studying the cosmos and has arrived at a conclusion that even he finds unsettling. What makes Loeb's hypothesis particularly compelling isn't just the unusual properties of Atlas itself, but the pattern it represents. Consider this: in the span of 8 years, we've detected 3 interstellar objects. For most of human history, we detected 0. Now we're averaging 1 every few years. Either we've suddenly become remarkably good at spotting these rare visitors, or they're not as rare as we thought. And if they're not rare, what does that say about the universe around us? The trajectory analysis of Atlas reveals something that makes even skeptical astronomers pause. The object's path through our solar system will bring it close enough to Venus, Mars, and Jupiter to conduct detailed observations of each world, should it possess the appropriate sensors. It's as if someone plotted a grand tour of our most interesting planets, careful to avoid any trajectory that might be interpreted as threatening, while maximizing observational opportunities. Dr. Sarah Chen, a planetary dynamics specialist at MIT, who has reviewed Loeb's calculations, admits the trajectory is statistically improbable for a random object, but not impossible. The question is whether we're seeing the work of physics or planning. And honestly, the mathematics could support either interpretation. The James Webb Space Telescope's observations of Atlas have revealed a chemical composition that reads like a deliberately crafted signature. The extreme abundance of carbon dioxide, the precise ratios of other compounds, the presence of carbonyl sulfide and cyanide gas in concentrations that mirror solar system comets, yet exceed them in specific ways, all combine to create what some researchers are calling a chemical camouflage. Wahag, think of it this way: if you wanted to build a spacecraft that could pass through alien solar systems undetected, how would you disguise it? You might cover it in ice and rock, program it to outgas materials that would create the appearance of cometary activity, and carefully calculate the ratios of those gases to match what the observing civilization would expect to see from a natural object. You'd want it to look familiar enough not to raise immediate alarms, but unusual enough that curious scientists would study it closely, gathering data on their technological capabilities and scientific knowledge in the process. The carbon dioxide abundance in Atlas's coma isn't just high, it's precisely high. The 8:1 ratio of CO2 to water is exactly what you might expect from an object that has been wandering through interstellar space for billions of years, exposed to cosmic radiation that would gradually convert water ice into carbon dioxide. It's chemically plausible, mathematically elegant, and just unusual enough to generate intense scientific interest. But here's what keeps some researchers awake at night. the timing of the outgassing. Atlas began showing cometary activity while still 4 astronomical units from the Sun, far earlier than most comets become active. It's as if the object knew it was being watched and began its performance precisely when it would be most visible to our telescopes. The activity increased gradually, following patterns that suggest not random sublimation of ice, but controlled release of materials designed to create and maintain a specific spectral signature. Dr. Elena Vasquez, a spectroscopist at the European Southern Observatory, has been analysing the gas emissions from Atlas for months. What we're seeing, she explains, is chemically consistent with a very old, very processed comet. But the patterns of emission, the timing, the precise ratios, they're almost too perfect. It's like looking at a photograph that's so sharp, so well composed, that you begin to suspect it might not be candid. The presence of atomic nickel vapor adds another layer to the mystery. While nickel has been detected in other comets, it's usually associated with iron and appears only when objects are very close to the Sun. Atlas is producing nickel vapor while still relatively distant, suggesting either an unusual composition or an artificial process designed to create specific observational signatures. Perhaps the most unsettling aspect of Atlas isn't what it's doing now, but how long it's been travelling to get here. Based on its galactic trajectory and velocity, astronomers estimate that Atlas has been wandering through the Milky Way for somewhere between 7.6 and 14 billion years. To put that in perspective, our universe is only 13.8 billion years old. Atlas may have been launched when the cosmos was still young, when the first generation of heavy elements was just beginning to form in stellar cores. This raises profound questions about its origin. What civilization could have existed that long ago? What technology could survive a journey measured not in years or centuries, but in geological epochs? If Atlas is artificial, it represents engineering capabilities so far beyond our current understanding that it might as well be magic. The object's trajectory through the galaxy suggests it originated from the thick disk of the Milky Way, a region populated by older stars with lower metallicity than our own Sun. These are stars from an earlier era of galactic evolution, when the universe was younger and the chemical composition of space was fundamentally different. If Atlas was created by a civilization orbiting one of these ancient stars, it would have been built using technologies and materials that predate Earth itself. Consider the implications. A probe launched billions of years ago, programmed with a mission so long-term that its creators knew they would be extinct before it reached its destination. A device designed to operate autonomously for longer than complex life has existed on Earth, following instructions written in the infancy of the galaxy. It suggests a level of forward thinking and technological sophistication that challenges our understanding of what's possible. Dr. Michael Garrett, director of the Jodrell Bank Center for Astrophysics, has been studying the long-term dynamics of interstellar objects. If Atlas is artificial, he notes, it represents a type of technology we can barely conceptualize, not just the ability to build something that lasts billions of years, but the foresight to launch it toward a star system that wouldn't even exist for another 3 billion years. It implies our understanding of galactic evolution and stellar formation that we're only beginning to develop ourselves. The mathematics of such a journey are staggering. To accurately predict where our solar system would be after a 10 billion year journey requires not just advanced physics, but perfect knowledge of galactic dynamics, stellar evolution, and gravitational interactions across cosmic timescales. It's as if someone solved an equation so complex that we're only now learning how to write it. But perhaps the most chilling possibility is that Atlas isn't alone. If one civilization possessed the technology and motivation to send probes across such vast distances and time spans, others might have as well. We might be living in a galaxy crisscrossed by ancient watchers, silent sentinels launched by civilizations that rose and fell before our sun was born, each following its own mysterious agenda in the darkness between the stars. As Atlas continues its approach toward the Sun, reaching its closest point in late October, the questions it raises become more pressing. Are we witnessing the passage of an ancient messenger, carrying information about our galaxy's deep past? Or are we being studied, catalogued, and assessed by intelligences so old and advanced that we cannot even comprehend their motives? The evidence is mounting, the implications are staggering, and the truth may be more terrifying than we're prepared to accept. As we drift deeper into this cosmic mystery, one thing becomes clear. 3i Atlas is changing our understanding of what's possible in the universe and what might be watching us from the darkness beyond the stars. But the most disturbing discoveries about Atlas are yet to come, hidden in data that's still being analysed and patterns that are only now beginning to emerge. In our next exploration, we'll delve into the mounting evidence that has even skeptical scientists questioning whether we're alone as we examine the signal hidden in starlight, why scientists fear we're being watched. As October approaches and Atlas draws closer to the Sun, something extraordinary is happening in observatories around the world. Teams of astronomers are working around the clock, not just to study this enigmatic visitor, but to search for others. Because if Atlas is what some researchers suspect it might be, then it's almost certainly not alone. The implications of this possibility have led to the quiet formation of what insiders are calling the Deep Survey Project, an informal network of astronomers using every available telescope to scan the sky for similar objects. What they're finding is both fascinating and deeply unsettling. Over the past 6 months, at least 17 objects have been detected that exhibit unusual trajectories or spectral signatures. Most are too distant or faint for detailed analysis, but their presence suggests something that challenges our fundamental assumptions about interstellar space. Dr. Lisa Chen at the Palomar Observatory has been coordinating much of this effort. Working through the quiet hours before dawn, she and her team have been mapping what they call trajectory anomalies, objects whose paths through space seem just a little too precise, a little too purposeful. We're seeing patterns, she admits, her voice carrying the weight of someone who has glimpsed something profound and disturbing. Not obvious ones, but when you plot the data over time, certain corridors through space seem to be more travelled than others. It's as if there are highways out there that we're only now beginning to perceive. The mathematics are subtle but compelling. Random objects moving through interstellar space should exhibit truly random trajectories, distributed evenly across all possible directions and velocities. But the growing catalogue of interstellar visitors shows clustering, both in direction of origin and in the timing of their arrivals. It's statistically improbable, but not impossible. The question that haunts researchers is whether they're seeing the signature of natural galactic processes or evidence of something far more deliberate. Consider the timing of these discoveries. In 2017, we detected our first interstellar visitor. By 2025, we've confirmed 3 and have candidates for many more. Either our detection capabilities have improved dramatically, which they have, or the frequency of these visits has increased, which would be deeply puzzling from a natural perspective. But if these objects are artificial, if they're part of some vast survey or monitoring system, then an increase in activity might indicate that something has changed. Something that has made our solar system more interesting to whatever intelligence might be watching from the darkness between the stars. Atlas itself may provide clues about the nature of this hypothetical surveillance network. Its chemical signature, that unusual abundance of carbon dioxide, might not just be camouflage, but a form of identification. A way for different probes to recognize each other, or for their creators to distinguish between various missions and objectives. The cyanide gas emissions, detected by ground-based telescopes, add another layer to this chemical fingerprint. In biochemistry, cyanide compounds are often associated with information storage and transmission. Could Atlas be broadcasting its findings as it travels, sending data back to some unimaginably distant receiver? The possibility becomes even more intriguing when we consider the object's age. If Atlas has been travelling for 10 billion years, it has witnessed the evolution of our galaxy in ways we can barely imagine. It has passed through stellar nurseries, where new suns were being born, skirted the edges of dying systems, where planets were being consumed by expanding red giants, and drifted through the vast emptiness between spiral arms, where only the hardiest of cosmic wanderers survive. What stories might such an ancient traveller carry? What data has it collected about the rise and fall of civilizations across the galaxy? If Atlas is indeed an artificial construct, it represents not just advanced technology, but institutional continuity on a scale that dwarfs human history. The civilization that created it would have needed to plan not just for their own extinction, but for the extinction of their stars, their solar system, perhaps even their local cluster of stars. Recent analysis of Atlas's radio emissions has revealed something that has caused considerable excitement and no small amount of concern among radio astronomers. The object is not just passively reflecting radio waves from Earth and the Sun, it's generating its own electromagnetic signature, subtle but detectable, in frequencies that correspond to no known natural process. Dr. Rajesh Patel at the Arecibo Successor Facility has been monitoring these emissions for weeks. The signal is incredibly weak, he explains, but it's there and it's structured. Not random noise, but organised patterns that repeat every 4.7 hours. That's almost exactly the rotation period we've calculated for the object's nucleus. It's as if Atlas is transmitting something in sync with its rotation, like a cosmic lighthouse sending the same message over and over again. The message, if it is indeed a message, is encoded in frequency modulations so subtle that they were initially dismissed as instrument noise. Only when multiple observatories began comparing data did the pattern become apparent. It's not the kind of signal that SETI researchers have been training to detect. No obvious mathematical progressions or prime number sequences. Instead, it's something far more sophisticated, embedded in the natural radio emissions of the object in a way that would be nearly impossible to detect without advanced signal processing techniques. The frequency of transmission is particularly intriguing. It falls within what radio astronomers call the waterhole, a relatively quiet region of the radio spectrum between the emission lines of hydrogen and hydroxyl radicals. This region has long been considered the most likely frequency for interstellar communication because it's naturally quiet and would be recognizable to any civilization that understands chemistry. The fact that Atlas is transmitting in this frequency range could be coincidence, but it could also be a deliberate choice by designers who understood the principles of interstellar communication. More disturbing is what the signal appears to be describing. Computer analysis of the transmission patterns suggests they contain information about solar system dynamics, planetary positions, and gravitational interactions. It's as if Atlas is broadcasting a real-time report on the structure and behavior of our solar system, transmitting data that would be invaluable to any intelligence planning to visit or understand our cosmic neighborhood. Dr. Maria Santos, a cryptanalyst who normally works on terrestrial intelligence projects, has been enlisted to help decode the transmissions. If this is a message, she says, it's unlike anything in our experience. There's no obvious beginning or end, no clear structure that we can identify. But there are patterns, mathematical relationships that suggest the presence of intelligence. It's like listening to a conversation in a language we don't understand, but recognizing that it is indeed a language. The implications of these findings have led to quiet discussions at the highest levels of government and scientific institutions. If Atlas is transmitting data about our solar system, who is receiving that data, and what might they be planning to do with it? The questions venture into territory that makes even experienced researchers uncomfortable, touching on issues of planetary security and humanity's place in a potentially crowded galaxy. But perhaps the most unsettling aspect of the radio emissions is their apparent age. Spectral analysis suggests that Atlas has been transmitting this signal for a very long time, possibly millions of years. The equipment required to maintain a coherent radio transmission across such timescales represents technology so advanced that it challenges our understanding of what's physically possible. It's one thing to build a probe that can survive a billion-year journey through space. It's another entirely to build one that can continue operating and transmitting throughout that entire journey. As we move deeper into October, Atlas is approaching its closest point to the Sun, and the behavior of this mysterious object is becoming increasingly difficult to explain through natural processes alone. The outgassing of carbon dioxide has intensified dramatically, but not in the random, chaotic way typical of comets. Instead, the emissions are occurring in precise bursts, timed with mathematical precision that suggests active control rather than passive sublimation of ice. Ground-based observations have detected what appear to be structural changes in the object's coma, the cloud of gas and dust surrounding its nucleus. These changes follow patterns that correlate with Atlas's radio transmissions, as if the object is deliberately modulating its appearance in response to some internal programming or external command. Dr. James Harrison, using the Very Large Telescope in Chile, has been monitoring these changes with increasing fascination and concern. What we're seeing, he reports, defies conventional cometary physics. The coma is expanding and contracting in ways that suggest active manipulation of gas release. It's as if someone is operating controls, adjusting the output to maintain specific visual and spectral characteristics. However, the timing of these changes is particularly significant. They began intensifying just as Earth-based radio telescopes started detecting the object's transmissions, almost as if Atlas became aware that it was being studied and began responding accordingly. This correlation could be coincidental, but the mathematical precision of the timing suggests otherwise. Even more intriguing is the apparent response to specific observational attempts. When the Hubble Space Telescope was directed toward Atlas for detailed imaging, the object's radio emissions changed frequency slightly for exactly the duration of the observation, then returned to their previous pattern. When the James Webb Space Telescope conducted its spectroscopic analysis, similar frequency shifts occurred. It's as if Atlas knows when it's being watched and is somehow acknowledging that attention. These observations have led some researchers to propose controlled experiments, attempting to communicate with the object through directed radio transmissions. The proposals are controversial, touching on questions of planetary security and first contact protocols that humanity has never seriously had to consider. If Atlas is indeed artificial, if it is capable of recognizing and responding to observation, then any attempt at communication carries profound implications for our species and our world. Dr. Elena Rodriguez, a specialist in communication theory at Stanford, has been developing protocols for such an attempt. If we're dealing with an artificial intelligence that has been operating for billions of years, she explains, we need to be extraordinarily careful about how we approach it. This isn't a matter of saying hello. This is potentially making contact with a form of intelligence so ancient and advanced that our relationship to it might be analogous to that between an ant and a human researcher. The ethical implications are staggering. Do we have the right to speak for all of humanity in making such contact? What if Atlas is not alone, but part of a larger network that has been quietly observing us for millennia? What if our detection of this object, our growing understanding of its true nature, represents a kind of cosmic graduation, a moment when a young civilization demonstrates sufficient technological capability to warrant direct contact? As Atlas approaches its closest point to the Sun, scheduled for late October, the questions multiply faster than the answers. The object will be visible to multiple space-based observatories simultaneously, providing unprecedented opportunities for detailed study, but it will also be broadcasting its mysterious signals at maximum power, potentially alerting any listeners to our growing awareness of its presence. The next few weeks may determine not just our understanding of this enigmatic visitor, but our place in a universe that may be far more populated and far more watched than we ever dared imagine. As Atlas continues its ancient journey through our solar system, carrying secrets that span geological ages and technologies that challenge our deepest assumptions about what's possible, one thing becomes increasingly clear: we are not alone. We may never have been alone, and the implications of that realization are only beginning to unfold. The evidence continues to mount, the patterns become more difficult to dismiss, and the possibility that we are witnessing something unprecedented in human history grows stronger with each passing day. As we prepare for Atlas's closest approach, as we ready our instruments and prepare our minds for whatever revelations may come, we must confront the possibility that this moment represents not just a scientific discovery, but a fundamental turning point in our understanding of our place in the cosmos. But the most startling discoveries about Atlas's true nature are yet to be revealed, hidden in the final phase of its approach to our Sun, where the intense solar radiation may force this ancient wanderer to reveal capabilities that will forever change our understanding of what lurks in the darkness between the stars. As October's final days arrive and Atlas reaches its closest approach to our Sun, something extraordinary begins to unfold. At precisely 1.4 astronomical units from our star, the same distance that would place it just inside Mars's orbit, the object undergoes what can only be described as a transformation. The change begins subtly, noticed first by automated monitoring systems that detect a shift in the object's electromagnetic signature. The radio transmissions that have puzzled researchers for months suddenly increase in both power and complexity. Where before there were simple, repetitive patterns, now there are layered sequences of increasing sophistication, mathematical progressions that build upon themselves like a cosmic symphony reaching its crescendo. Dr. Amanda Foster at the Deep Space Network facility in California is among the first to recognize what's happening. Working through the pre-dawn hours, she watches her screens fill with data that defies every protocol in her experience. The signal strength has increased by a factor of 12, she reports to colleagues around the world, her voice carrying a mixture of excitement and apprehension. But it's not just louder, it's more structured, more purposeful. It's as if Atlas has been waiting for this moment, this precise distance from the Sun, to reveal its true capabilities. The timing cannot be coincidental. For months, Atlas has maintained a steady but subtle transmission pattern, barely detectable above background noise. Now, as solar radiation bathes the object in energy, it responds not like a passive comet sublimating ice, but like a machine awakening from a long dormancy. The implications send ripples of unease through the astronomical community. Spectroscopic analysis reveals that the object's surface is changing in ways that have nothing to do with normal cometary activity. Instead of the random, chaotic outgassing expected from a body of ice and rock heated by solar radiation, Atlas is exhibiting controlled emissions from specific locations on its surface. These emission points form geometric patterns, precise arrangements that shift and evolve as the object rotates. Dr. Chen's team at Palomar has been tracking these surface changes with unprecedented detail. We're seeing what can only be described as active sites, she explains, her words carefully chosen. Regions of the surface that are behaving independently, releasing materials in coordinated patterns. If this were a natural comet, we would expect uniform heating and random outgassing. What we're observing is the opposite of random. The geometric patterns are particularly troubling. As Atlas rotates on its axis every 4.7 hours, the active sites trace complex mathematical curves across its surface. These curves, when mapped and analysed, correspond to solutions of advanced differential equations, mathematical relationships that describe everything from orbital mechanics to electromagnetic field interactions. It's as if the object's surface is displaying a textbook of physics written in gas and dust. Perhaps most unsettling is the object's apparent awareness of its observers. When multiple Earth-based telescopes focus on Atlas simultaneously, the emission patterns change, becoming more complex and more organized. When space-based observatories join the observations, the changes become even more pronounced. It's as if Atlas can sense when it's being watched and responds accordingly, like a performer acknowledging its audience. The revelation that Atlas may be responding to observation has triggered what insiders are calling the Deep Field Protocol, an unprecedented level of international cooperation among space agencies and astronomical institutions. Never before have so many resources been focused on a single object, and never before has the data raised such profound questions about our place in the universe. The protocol involves coordinated observations from every major telescope on and off Earth, from the venerable Hubble to the cutting-edge James Webb, from ground-based radio arrays to deep space monitoring stations. The goal is simple in concept, but staggering in scope: to gather every possible piece of information about Atlas before it disappears back into interstellar space, potentially forever. What they're finding challenges not just our understanding of comets and asteroids, but our fundamental assumptions about intelligence and technology on cosmic scales. The radio transmissions from Atlas have evolved into what can only be described as a language, complete with syntax, grammar, and recursive structures that suggest abstract thought and complex reasoning. Dr. Sarah Kim, a linguist specializing in mathematical communication who has been brought in to analyze the transmissions, describes her work with a sense of awe and trepidation. We're dealing with a form of communication that operates on multiple levels simultaneously, she explains. There's the basic mathematical content, which describes physical processes and relationships. But layered beneath that is something more sophisticated, patterns that suggest memory, learning, and adaptation. It's as if we're listening to the thoughts of something unimaginably ancient and intelligent. The mathematical content of the transmissions is particularly revealing. Atlas appears to be broadcasting detailed information about stellar evolution, galactic dynamics, and the formation of planetary systems. But this isn't textbook knowledge. It's observational data, the kind of information that could only be gathered through direct experience across cosmic timescales. Some of the data describes stellar systems that no longer exist, stars that died billions of years ago, but are catalogued in Atlas's transmissions with the precision of a contemporary observation. Other portions describe the formation of heavy elements in stellar cores, the dynamics of spiral galaxy rotation, and the distribution of dark matter on the largest scales of the universe. It's an archive of cosmic history spanning geological ages, transmitted by something that has apparently witnessed it all firsthand. Dr. Michael Santos, a cosmologist at the European Space Agency, has been analysing these cosmic histories with growing amazement. If Atlas is indeed artificial, he notes, it represents not just advanced technology, but institutional memory on a scale we can barely comprehend. This object has been collecting data about our galaxy for longer than complex life has existed on Earth. It's a library, an archive, a witness to the deep history of the cosmos. But the transmissions contain more than just astronomical data. Embedded within the mathematical descriptions are what appear to be cultural and technological artifacts, information about civilizations that rose and fell while Atlas wandered between the stars. These fragments are tantalizing and incomplete, like pages torn from history books, written by minds we cannot imagine. As Atlas reaches its closest point to the Sun on October 30th, something unprecedented occurs. For exactly 47 minutes, the object's transmissions change completely, abandoning the complex mathematical patterns it has maintained for months in favor of something startlingly simple and recognizable. The new transmission consists of prime numbers transmitted in sequence from 2 to 1009, followed by the Fibonacci sequence up to the 144th term. Then, in a pattern that sends chills through observatories around the world, it transmits the first 100 digits of pi, followed by the mathematical constants e and the golden ratio. These are the universal mathematical truths that any technological civilization would recognize. The cosmic calling cards that SETI researchers have long anticipated as the signature of artificial intelligence. But the sequence doesn't stop there. After completing its mathematical introduction, Atlas begins transmitting something that appears to be a star map, coordinates and distances describing the positions of stars as they existed billions of years ago. At the center of this ancient map is a star system located in what we now know as the thick disk of our galaxy, a region populated by the oldest stellar populations in the Milky Way. Dr. Elena Rodriguez, who has been coordinating the international response to these transmissions, recognizes the significance immediately. This isn't just communication, she realizes, her voice barely above a whisper. This is an introduction. Atlas is telling us who it is, where it came from, and how long it has been traveling. It's providing credentials, establishing its authority to speak on matters of cosmic significance. So basically, the coordinates in the star map correspond to a system that existed approximately 10 billion years ago, orbiting a star that has long since exhausted its nuclear fuel and collapsed into a white dwarf. If Atlas originated from this system, it has been traveling through space for longer than our solar system has existed, carrying with it the final message of a civilization that died before Earth was born. But the most unsettling aspect of the recognition sequence is its timing. The transmission begins at the exact moment of Atlas's closest approach to the Sun, and ends precisely as the object begins its journey back into interstellar space. This timing cannot be accidental. It suggests that Atlas has been programmed to reveal its true nature only when it reaches a specific point in its trajectory, only when it has gathered sufficient data about our solar system and our technological capabilities. The implication is profound and disturbing. If Atlas is indeed an artificial probe, it has been studying us, evaluating our development, measuring our progress toward becoming a spacefaring civilization. The recognition sequence may represent a kind of cosmic report card, a summary of our species' readiness for your contact with intelligences that span the galaxy. Dr. James Patterson, a specialist in artificial intelligence at MIT, who has been analysing the structure of the transmissions, offers a sobering assessment. What we are seeing, he explains, is the signature of an intelligence that operates on timescales we can barely comprehend. Atlas has been patient in ways that challenge our understanding of what patience means. It has waited billions of years to deliver its message, and it chose to deliver it at the moment of our species' first glimpse of interstellar visitors. The recognition sequence concludes with something that appears to be a farewell, a mathematical poem that describes the beauty of stellar birth and death, the dance of galaxies across cosmic time, and the precious rarity of worlds where life can take hold and flourish. It's a message of cosmic perspective, a reminder of our place in the vast tapestry of existence, and perhaps a gentle warning about the responsibilities that come with awareness of the universe's true nature. As Atlas begins its journey away from the Sun and back into the interstellar void, it leaves behind what researchers are calling a departure gift, a final transmission that may represent the most significant discovery in human history. The transmission lasts exactly 1 hour and contains what appears to be a compressed archive of scientific and technological information. The data is structured in layers of increasing complexity, beginning with fundamental physics and mathematics and progressing through chemistry, biology, and engineering principles that are centuries beyond our current understanding. Dr. Lisa Chang, leading a team of scientists attempting to decode this final message, describes the experience as overwhelming. It's like being handed the contents of a university library written by a civilization millions of years more advanced than our own, she explains. The information is organized in a way that suggests it's meant to be understood progressively, like a curriculum designed to guide a developing civilization through increasingly sophisticated concepts. The early layers of the archive contain confirmations and clarifications of physical laws we already understand, but with precision and elegance that far exceed our current formulations. Einstein's equations are presented in more general forms. Quantum mechanics is unified with gravity through mathematical structures. We're only beginning to glimpse, and the fundamental forces of nature are revealed to be different aspects of a single underlying principle. But as the decoding teams progress deeper into the archive, they encounter concepts that strain the boundaries of human comprehension. There are descriptions of technologies for manipulating space-time itself, methods for harnessing the zero-point energy of vacuum fluctuations, and principles for creating stable wormholes that could allow instantaneous travel across galactic distances. Perhaps most intriguingly, there are sections that appear to describe other civilizations, other species that have achieved technological sophistication comparable to that of Atlas's creators. These descriptions are fragmentary and cryptic, but they paint a picture of a galaxy far more populated and complex than we have ever imagined. Dr. Maria Santos, working on the biological sections of the archive, has found information that could revolutionize our understanding of life itself. There are descriptions of biological processes that operate on quantum mechanical principles, she reports. Living systems that can exist in superposition states, organisms that process information using quantum entanglement, life forms that exist partially in higher dimensional spaces we can't even perceive. The technological sections of the archive are equally astounding. There are blueprints for devices that could extend human lifespan indefinitely, methods for uploading consciousness into quantum computational matrices, and techniques for creating artificial realities indistinguishable from physical existence. It's a roadmap to transcendence, a guide to becoming the kind of civilization that could create something like Atlas itself. But embedded throughout the archive are warnings, subtle cautionary notes about the dangers that accompany such advanced knowledge. There are references to civilizations that destroyed themselves through technological hubris, species that became extinct by venturing too far into realms they didn't fully understand, and the delicate balance required to survive the transition from planetary to galactic civilization. As Atlas fades from view, disappearing back into the darkness between stars, astronomers around the world continue to monitor the skies with new urgency. The departure gift has changed everything, providing not just knowledge, but context for humanity's place in a universe that is clearly far more complex and populated than we ever suspected. The search for additional interstellar objects has intensified dramatically, with every major observatory dedicating time to scanning for visitors that might follow patterns similar to Atlas, and they are finding them. Over the past month, 17 additional objects have been detected with trajectories that suggest interstellar origins, though none have approached close enough for detailed study. Dr. Elena Rodriguez, now leading what has been formalized as the Interstellar Object Monitoring Network, describes the new reality with a mixture of excitement and apprehension. We appear to be living in a galaxy where ancient probes and monitors are more common than we ever imagined, she explains. Atlas may not have been unique. It may have been one of thousands, perhaps millions, of similar objects that have been quietly observing and cataloguing civilizations throughout the Milky Way. The implications for human civilization are staggering. If we are indeed being watched by intelligences that have survived for billions of years, if our development is being monitored and recorded by artificial minds of unimaginable sophistication, then every decision we make as a species takes on cosmic significance. We are not alone in the universe, and we may never have been alone. But perhaps most unsettling is the realization that Atlas's departure may not be an ending, but a beginning. The recognition sequence it transmitted, the detailed information it gathered about our solar system and our technological capabilities, may have been a report to intelligences that remain hidden in the darkness between stars. Dr. Sarah Kim, still analysing the linguistic patterns in Atlas's transmissions, has found evidence that suggests the object was not operating independently. There are elements in its communications that appear to be responses to signals we cannot detect, conversations with entities we cannot perceive. Atlas was talking to someone, she concludes, her words carrying profound implications. Throughout its time in our solar system, it was receiving instructions, reporting its findings, participating in a dialogue with intelligences we can only guess at. The departure gift itself may have been more than a gesture of scientific generosity. Some researchers believe it represents a test, a way of measuring how responsibly humanity will handle advanced knowledge. The information contained in the archive could propel our civilization forward by millennia, but it could also destroy us if applied without wisdom and restraint. As we process the implications of Atlas's visit, as we struggle to understand the knowledge it has left behind and prepare for the possibility of future encounters, one thing becomes clear. We are living through a moment of unprecedented significance in human history. We have made contact not with living beings, but with their technological legacy, and that contact has forever changed our understanding of our place in the cosmos. The universe is not empty. It is not silent. It is populated by intelligences so ancient and advanced that they move through space and time. Like currents in an ocean, we are only beginning to perceive. And now, for the first time in human history, we have proof that we are part of something vast and complex and beautiful beyond our current ability to comprehend. Atlas has departed, but its legacy remains, challenging us to grow beyond our planetary boundaries, to think in terms of cosmic timescales, and to prepare for a future where humanity takes its place among the civilizations that span the stars. The evidence is undeniable, the implications are staggering, and the future has never been more uncertain or more full of possibility. As we look up at the night sky with new eyes, as we contemplate the knowledge that has been gifted to us and the responsibilities that come with it, we must ask ourselves, are we ready for what comes next? Are we prepared to join the ancient community of minds that have been watching and waiting for us to take our first steps into the larger universe? The answers to these questions will define not just our immediate future, but our place in the cosmic story that has been unfolding for billions of years. And somewhere in the darkness between the stars, other watchers may already be making their way toward us, drawn by the signals Atlas has sent, curious about the young civilization that has finally learned to listen to the whispers in the void. In our next exploration, we'll delve into the most disturbing implications of Atlas's departure gift and examine the evidence that suggests we may not have much time to prepare for what's coming in the ancient signals, why scientists believe we're running out of time. In the months following Atlas's departure, a curious thing begins happening in observatories around the world. Astronomers start noticing patterns in their data that extend far beyond the immediate aftermath of our mysterious visitor. Deep space monitoring stations detect subtle variations in cosmic background radiation, changes so minute they would have been dismissed as instrument noise just years before. But now, with heightened sensitivity to the possibility that we are not alone, these whispers from the void take on new significance. Dr. Patricia Williams, working at the Atacama Large Millimeter Array, has been analysing these variations with the methodical patience of someone who understands that the universe rarely reveals its secrets quickly. The patterns she's discovering suggest something that challenges our understanding of how information moves through interstellar space. What we're seeing, she explains during a late-night video conference with colleagues scattered across 6 time zones, appears to be a kind of galactic communication network, operating on frequencies and timescales we've never considered. The network, if it exists, operates through modulations in the cosmic microwave background itself, the ancient echo of the Big Bang that permeates all of space. These modulations are incredibly subtle, requiring sophisticated analysis to detect, but they appear to carry structured information across distances that would make conventional radio communication impossible. It's as if the universe itself has been turned into a vast communication medium by intelligences capable of manipulating the very fabric of space-time. The implications are staggering. If such a network exists, it would allow for communication across the entire galaxy, possibly even between galaxies. Civilizations separated by thousands of light years could share information instantaneously, coordinating activities on a scale that dwarfs human comprehension. And if Atlas was part of such a network, its visit to our solar system may have been just one data point in a vast, ongoing survey of galactic civilizations. Dr. Rajesh Kumar, a theoretical physicist at Cambridge, has been working on the mathematical frameworks that might support such a communication system. His equations suggest that sufficiently advanced civilizations could indeed manipulate the quantum fluctuations in the vacuum of space, encoding information in patterns that would propagate faster than light while remaining invisible to primitive detection methods. It's not magic, he explains, his voice carrying the quiet excitement of someone who has glimpsed a deeper truth. It's just physics, operating on scales and in ways we're only beginning to understand. But the detection of this hypothetical network raises disturbing questions about humanity's place in it. If we are indeed being monitored and evaluated by ancient intelligences, what criteria are they using? What standards must we meet to be considered worthy of direct contact? And what happens to civilizations that fail to meet those standards? The answer may lie in the patterns themselves. As Dr. Williams and her team continue their analysis, they're beginning to detect what appear to be gaps in the communication network, regions of space where the subtle modulations suddenly cease. These dead zones correspond to areas where stellar surveys have detected evidence of extinct civilizations, systems with the chemical signatures of industrial activity but no current signs of life, worlds that appear to have been inhabited but are now silent. As we reach the end of our journey through the Atlas mystery, we're left with more questions than answers, and perhaps that's exactly as it should be. This ancient wanderer has shown us that the universe is far stranger and more populated than we ever dared imagine. Whether Atlas was natural or artificial may matter less than what it represents. A reminder that we are part of something infinitely larger than ourselves, observed perhaps by minds that span geological ages, connected to a cosmic community we're only beginning to perceive. Tonight, as you drift towards sleep, remember that somewhere in the darkness between stars, other mysteries are making their way toward us, carrying secrets that will continue to reshape our understanding of what it means to exist in this vast, whispering cosmos. Most sweet dreams.